Hi everyone. Okay, let's move on to the questions in 9.3. This one is working on the present value. So again, the formula for present value is your future value multiplied by 1 plus your periodic interest rate. And then once you solve what's in the bracket, then the exponent is your n, the number of periods over the life of the investment, negative. Okay, so you turn that into a negative by using the plus minus button. Okay, so for the first one, if money can be invested to earn 2.5% compounded annually, how much would be invested today to grow to 10,000 after 10 years, 20 years, and 30 years? Okay, so we have our givens. We know what our annual interest rate is. It's 2.5%. We know what the compounding per year is, your M, which is 1. And we know that our future value is $10,000. That's what we want. So how much do we need to invest today in order to have that based on the other information? Okay, so if it's going to be for 10 years, if we're going to invest it for 10 years, in order to get $10,000 in 10 years, then we would have to invest $7,811.98. So again, it's your 1.025 in your brackets. So your brackets has been solved. And then you put that into your calculator, 1.025. Click the y to the power of x button on your financial calculator. Then you'd put 10. Then you'd hit the plus minus button to make the number on the screen into minus 10 or negative 10. And then you'd hit the equals button. And that's going to give you the 7811.98. If we're going to invest it for a term of 20 years, so that we want 10,000 after 20 years, again, instead of having the negative 10, we're going to have an exponent of negative 20. So then we would have to invest $6,102.71 today. And if we want 10,000 in 30 years, we would change the exponent to negative 30, and we would have to invest today $4,767.43. Okay, what amount invested today would grow to 10,000 after 25 years if the investment earned 4% annually, 4% semi-annually, 4% compounded quarterly, and 4% compounded monthly? So by now, I'm sure everybody is confident in figuring out your periodic interest rate, which is your annual or nominal interest rate divided by the number of compounding periods in a given year, and that your N is the number of years multiplied by your M, which is the compounding the number of times it's being compounded in a year. Okay, so for your initial investment, we have your 1.04 because it's being done annually, and it's to negative 25, and therefore your solution is going to be 3751.17. For your second solution, where it's semi-annual, your exponent's going to be negative 50, so 3715.28. For your fourth one, because it's being compounded quarterly, your N is 100, so you need to turn that into negative 100, and your periodic interest rate is 1%. And then for the fourth one, D, we have an N of 300 because it is being compounded monthly for 25 years. So therefore, the exponent is negative 300. So therefore, if we're going to invest it for 25 years, we want it to grow to $10,000, and it's going to be compounded monthly using a 4% interest being earned, then today we would have to invest $3,684.92. Okay, so number 5, what is the present value of 10,000 discounted at 4.5% compounded annually? So again, that's just a different word that they're using. That just means that the interest rate, the annual interest rate, or the nominal interest rate, which means the exact same thing, compounded annually, so once a year over 10 years. So again, write out what you know. You know that your future value is going to be 10. We know that your J is 4.5. So in order to come up with your periodic interest rate, it's 4.5 divided by M, which is the number of times it's being compounded in a year, which is only 1. So your annual interest rate and your periodic interest rate are the exact same in this situation. Your N is 1, which is your M, your number of times it's being compounded in a year, multiplied by 10 years gives 10 periods. So your N is 10. So again, we're trying to figure out what the present value is. So we've got 10,000 as our future value. In our brackets, which is your 1 plus your periodic interest rate, is 1.045. So we put 1.045 into our calculator. As soon as we put in 1.045, we hit the y to the power of x button. Then we click 10. Then click the plus minus button. Then on your screen, you're going to see that it's now showing as a negative 10. And then we're going to hit equal. And that's going to give us $6,439.28. For number 9, if your client's objective is to have 10,000 in 4 years, how much should he invest today in a product earning 5.5% compounded annually? So again, we've got our I, our periodic, is 5.5. We have an N of 1 multiplied by 4 gives us 4. Future value is $10,000. So therefore, the required investment in today for our client is $8,072.17. Okay, and we have one more problem here, which is a review problem. We have Accurate Accounting obtained a private loan of $25,000 for 5 years. No payments were required, but the loan accrued interest at a rate of 9% compounded monthly for the first 2.5 years, and then 8.5% compounded semi-annually for the remainder of the term. What total amount was required to pay off the loan after 5 years? So the first thing we need to figure out is, what do we know and what are we trying to solve? Okay, so they obtained a private loan of $25,000 for 5 years. So $25,000 is our present value. 5 years is the number of years. No payments were required, but the loan accrued interest at a rate of 9%. So we know that our annual or our nominal interest rate is 9%. Compounded monthly, so there's our M, and for the first 2.5 years. So even though the loan is for 5 years, the situation changes after 2.5. Remember, we did a question like this back when we were doing the future value. So your best bet here is to draw a timeline. Okay, so we need to figure it out in 2 steps. So the first step is based on the 2.5 years. Okay, so let's do that part first. So we've got our future value equals 25,000, which is our present value. We've got 1.0075 as our periodic interest rate. And we get this by taking J, our 9%, divided by M, the number of compounding periods in a year, and that is going to give us 0.75%, okay, as our periodic. So therefore, to put it into our formula, we need to change it to a decimal. So it's 1.0075. Now, what do we figure for our N? So in order to get our N, we take the number of compounding periods in a year, our M, which is 12. The number of years is 2.5. So 12 times 2.5 gives us the 30. So therefore, it is 1.0075 to the power of 30. So remember, we're doing the future value here. So the number is a 30, not a negative. Okay, so we put in our calculators 1.0075, click the y to the power of x button, then put in 30 and hit equals. That's going to give us a future value in 2.5 years of 31,281.79 cents. Okay, so now where we're still in the midst of an equation, use all the decimals given. So if it works out to 0.794, use the full 0.794. Okay, so now in step 2, we need to figure out after the 2.5 year mark, what is it going to equal given the next set of situations, because it changes at the 2.5 year mark. So again, we're trying to figure out what the future value is after the next 2.5 years, because the total term is 5 years. Okay, so we've got our J, or annual or nominal interest rate, of 8.25%. Our M is 2 because it's being compounded semi-annually. Our N, so the number of periods over the life, is 2 multiplied by 2.5. So therefore our N is 5. So now we're going to figure out as well what our I is. So our I is J, which is your 8.25% divided by 2, gives you 4.125% for your periodic interest rate. So to put that into your bracket, you come out with 1.04125. That's to the power of 5. That's your N. So you put that in your calculator, 1.04125. Click the y to the power of x button. Then put in 5 and equals. Then you're going to multiply that by your 31,281.794. And that's going to give you the ultimate future value for this situation of $38,288.36. Let me know if you have any questions, okay? Thanks, everyone.